returns to scale and our cost function. In particular, we're going to look at the average cost function here. So let's first of all remind ourselves what returns to scale are. So reminder. So constant returns to scale, so CRS for short. Constant returns to scale is when, if we increase the amount of inputs by some constant proportion, so each of them, like doubling them, like t could equal 2, and we double the amount of inputs, and it would result in double the amount of output. So remember, that was constant returns to scale. We're going to call that 1. 2, we're going to have increasing returns to scale. And this is, for instance, if we want to use our t equals 2 example again, if we double the amount of each of the inputs, we get more than double the amount of output. And finally, 3 is decreasing returns to scale. This is when, again, if we double the amount of input, we get less than double the amount of output. Okay, so that's just a quick reminder, because we're going to talk about, we're going to categorize what happens with the cost function separately for these kind of examples. So let's start with 1 here, when we have constant returns to scale. So suppose we have solved our cost minimization problem. And we get some unit cost function. C, W1, W2, and 1. So this is like y equals 1. So this is our minimum cost of producing 1 unit. Of producing 1 unit. If we had constant returns to scale, the cheapest way to produce y units would then just be this unit cost function times y. Because the cost function is linear in output. So if we have constant returns to scale and we figure out what the cost minimization function is, this cost function here, we figure out what it is when we have 1 unit of output. If we have constant returns to scale, then we can just take this unit cost function and multiply it by y in order to get the cost function for what, a general y level of output. So it's a linear, the cost function, this cost function is linear with respect to output. Now we can also think of these 2 other cases. If we have increasing returns to scale, then it's going to be, it's not going to be linear with respect to output. It's going to be less than linear with respect to output. As in, like, if we, here we're doubling the inputs and we get more than double the outputs. So here, costs will increase. So here costs increase linearly with output. Here costs will increase less than linearly. output. Because with increasing returns to scale, they can produce twice as much output at less than twice the cost. You can kind of see that with this increasing returns to scale here, right? If we can double the inputs and more than double the output, that means we need less than double the inputs to double the output, which means it's going to cost us less than twice the amount to produce twice as much output. So that's the idea there. And then you can see it's going to be the opposite with decreasing returns to scale. The costs are going to increase by more than linearly with output. More than linearly. With output. So it's going to cost you more than double to produce double the output. If output doubles, costs you more, costs more than double. Again, you can kind of see that with here. If we double the inputs and we get less than double the output, that means we have to more than double the inputs to get double the output. So the costs, if W1 and W2 are constant, which we're assuming they are here, so the unit costs of the input costs don't change, but it's going to cost us more than double. If we have decreasing returns to scale, it costs us more than double to double the output. And we can and we're going to be able to kind of summarize this relationship with what happens to the average cost of producing one of these units of production. So let's erase this board and kind of talk about average cost. This can be seen in the behavior of the average cost function. Which first year you probably saw represented by AC as well, average cost. So the average cost function is just like the per unit cost of producing Y units of output. Okay. So mathematically, the AC, which is a function of output, is going to be equal to our cost curve, like our cost function, the minimum cost of producing Y units of output, which depends on W1, W2, and how much we're producing, divided by Y, right? This is the total cost of producing Y units of output. Again, it's the one that minimizes the cost of production. We divide it by how much we're producing, we get the cost per unit of producing Y units of output. Okay. We have constant returns to scale, then AC, Y, average cost per producing Y units, is just going to be C, W1, W2. Here's that unit cost function, the cost of producing one unit. And we saw that if we multiply that by Y, we get the cost of producing Y units. Put that over Y. These will cancel out. And we just have what's left over is just the unit cost function. So there's like a constant average cost. Of production. So that's if we have constant returns to scale, we have like a constant average cost of producing. As we produce more, the cost per unit doesn't change. So this was when we had increasing returns to scale. So we don't have that linear relationship anymore. Remember that output is going to more than double when we double the amount of inputs. Well, that means the average cost of production is going to decrease as we produce more. So what this means is as Y increases, average cost will decrease. And finally, we have decreasing returns to scale. The average cost is going to be increasing as we produce more. So, as Y increases, average cost will increase. And so, it's important to note that like a given technology can have all these three things true at different levels of production. So, there could be points in production where we have increasing returns to scale. Maybe at the beginning, as we are able to specialize in production processes, have people specialize, we have increasing returns to scale. And then maybe at some level of output, we get constant returns to scale. And then eventually, we might get decreasing returns to scale. And so we could have an average cost function that displays all these three properties. We can have regions of constant returns to scale, increasing returns to scale, and decreasing returns to scale at different levels of production. So what this means is the AC could be increasing, decreasing, or constant. So from now on, what we're going to kind of do is assume, and we've been kind of doing this as we've gone, but we're kind of assuming that the W1 and W2 are constant. And so then it's going to make it easier just to kind of write our cost function as just the cost as a function of output, because W1 and W2, the two input prices, don't change. So we're going to start to assume that going forward. It's going to clean up our notation just a little bit.